Find the distance from the origin to the plane passing through the point 101 and containing the line t1 5 minus t. Let's take this first. We're used to seeing parametric equations for lines. In the x, y, and z, this is r of t, your position function. It's not written like that. But anyway, x is t, y is 1, z is 5 minus t. Okay. Let's fill in the gaps then with zeros. 0 plus t, and then 1 plus 0 t's. So we have a point 0, 1, 5 and a direction vector 1, 0, negative 1. Alright, so that's how we're more used to seeing equations of lines. I need the plane passing through the point and the line. To get the equation of a plane, we're going to need a normal vector to the plane and a point in the plane. This is the point in the plane. We'll call this the point in the plane, although the other point, 0, 1, 5, is also in the plane. So we use this as the point in the plane. Now the normal vector to the plane is not that direction vector for the line. Basically we have, I'm in search of a line, I'm in search of a plane that has a point given 1, 0, 1 and a line given as the parametric equations. To get the normal vector to the plane, what I can do is take a point that's on the line, get the vector that connects that point to your other point, and take the direction vector for the line, cross those two vectors, and that would give me a normal vector to the plane. Okay, so I have the point 1, 0, 1 and the point 0, 1, 5 on the line. I don't know, call this guy P and Q. I'm going to get the vector from P to Q. That would be my purple vector. The vector from P to Q is my purple vector. And I subtract from Q's coordinates, I subtract P's coordinates. So 1, negative 1, negative 4 would be the purple vector. And then the red vector is 1, 0, negative 1, the direction vector for the line. I cross these two guys to get the normal vector to the plane. Call this guy U and this guy V, and we need to cross U and V to find the normal vector to the plane. So we have 1, negative 1, negative 4, and 1, 0, negative 1. So the cross product is going to be 1 for the I component, the opposite of negative 1 plus 4 for the J component, and 0 plus 1 for the K component. And we're going to call this N, the normal vector to the line. that's a negative 1 there, so that's a 3. So 1, negative 3, 1. That's the normal vector to the plane. Alright, great. Normal vector to the plane, point in the plane, the equation of the plane, then this plays the role of A, B, and C in the equation of the plane. So the equation of the plane is found by taking AX1, or AX naught plus BY naught plus CZ naught. And we just have to figure out what D is now. So we take 1 times 1, negative 3 times 0, 1 times 1, plus D should be 0. Looks like D is negative 2. Yeah. So D is negative 2. And the equation of the plane then is x minus 3y plus z minus 2 is equal to 0. You should probably double check and make sure that this plane also goes through the point 0, 1, 5, the point that was on the line, and it does. So we're good then. That's the plane. Now find the distance from the origin to the plane. Okay? The distance between a point and a plane can be given by this formula from the notes. And so where x1, y1, and z1 is the point, and the plane is axy plus ax plus by plus cz plus d equals 0. So we know who a, b, c, and d are, and x1, y1, z1 is the origin, only because they that's the point here, the origin. So x1 is 0 and y1 is 0. That makes things easier for us. And z1 is 0. So that we just get d. But notice the formula has absolute value in there. D is negative 2, but the formula has absolute value on it, so it's a positive 2. Denominator takes a squared and b squared, which is 9, and c squared, and so looks like we have square root of 11. So that would be our answer to the question. Yeah, 2 over the square root of 11 is the answer.